In this lab, we will continue um, with the UCI file, the bag of words, and and uh, uh, and we had words by dog. Just show you. We made a set of words by dog containing in a form of dictionary or set. It was a nested set where the first value was for the dog ID and the second set of values were for the word IDs. So here's the one. So, yeah, so for example, this 0 represents dog ID and this second set of values represent the word IDs. Now we define number of hash functions, that is the signature size. So in this lab, what we are doing is that we are computing MinHash signature for all documents with number of hash functions equal 10. So first we define the number of hash functions, that is the signature size. So number of hashes equal 10. And we are going to use random. So we will import random. Now in this step, we will write definitions to generate hash functions. So this is how we do that. So we will write definition generate hash function of number of words. So we know the number of words, which is, I'll just show you. So number of words was already given in the document. So if we just recall that, that's 6,906. So generate hash function of number of words. Let P equal 999983. Let I equal random dot rand int and then bracket 0 comma p minus 1. So what it will do is I'll just show you. So random rand int from 0 to p minus 1, that will be 999982, and that will give you 602,571. So this every time you run this, it will choose a different number. And let b equal random dot rand int from 0 to p minus 1. So for example, if I run this again, it's not going to give me 602,571. So it gives me 17,790. So it changes every time. Definition for hash function, and this x, which is unknown. So retain bracket. So I times x plus b. So close the bracket, mode p, close the bracket, and take the mode number of words. So what it will do, the mode is the value of this divided by p, and then take the remainder, and that remainder you divide by divided by number of words and then take the remainder. So it retains that value and retain hash function. And then we will use this generate hash function into we will call this generate hash function the number of hashes times. So number of hashes is 10. So we will call this generate hash function 10 times. Now when we run this, and then when we run and then when we call this function to generate the hash function, 10 times. So you see why it is 10 times. So definition, generate hash function, bracket, number of hashes, which is 10, comma, number of words, which is 6,906. So if we just um, recheck that one, number of words. So 6,906. So from 10 generate hash functions where number of hashes equal 10 and number of words equal 6,906 and retain. So it will retain the generate hash function. So this is calling this function over here of number of words. So the 6,906. So because number of words is used as mode in this function here to find the hash function for underscore in range 10 number of hashes. So it's called 10 times. Generate hash function is called 10 times. So when we call the function to find hash functions, this will give us 10 hash functions. So let's see, 3, 6, 9, 10. 10 hash functions. Now we will use these 10 hash functions in further to compute the MinHash signatures. Okay. So we know the word spare dog is in a dictionary form where the first value is for dog ID and the second set of values are the word IDs. Now we show working. So display length of words per dog and display number of dogs. So length of words per dog is 3430 and number of documents is 3430. Show working. So length of hash functions. Length of hash functions is this one over here. The functions that we found, and that is 10. Recheck that. And here there is another working. Show working. So NP. NP is import numpy. Has NP. So that's numpy library. So np dot zeros bracket and square bracket. 2 is for number of rows and 3 is for number of columns. So when we say np dot zeros for open bracket, open square bracket, length of hash functions, that will be 10. So number of rows will be 10 and number of columns for each of those rows will be number of docs, and number of docs is 3,430. So number of docs is the number of document IDs. Now we compute the MinHash signatures for all documents. So to compute the MinHash signatures for all documents, we will write a function. We will write a definition. So definition def compute signature matrix, and we will put the input as hash functions, the functions that we computed, and words per doc. Words per doc is the dictionary that we formed with the doc IDs and the word IDs. Number of hash functions equal length of hash functions, and we know that is 10. Number of docs equal length of words per doc, or that is number of documents, and that is 3,430. Signature matrix equal np dot zeros. So bracket, square bracket, number of hash functions, that will be 10 rows, comma, number of docs, that will be 3,430. So for doc ID in range number of docs, So number of docs is 3430. So for doc ID in range 3430 from 0 to 3429. For hash function index in range number of hash functions, which is 10, range 10. So it ranges from 0 to 9. Hash function equal hash functions of hash function index. So say if it is hash function index is 9, then hash functions 9 will be from the set of the functions, this hash function 9. Signature matrix bracket, that is square bracket, hash function index. So hash function index is in range number of hash functions, which is 10. So that was 10, 9 we are showing example of. So signature matrix 9, ninth row, and then another set of bracket, doc ID, and doc ID is in range number of docs, and number of documents is 3430. Let's say 3429 is the doc ID. So ninth row 3429 column will be minimum of hash function bracket word. So hash function, remember that X will be replaced by this word. So for word in word space ID of the doc ID. So doc ID was 3429. So word space doc of 3429. So all those words that are in words per doc of 3000 for doc ID 3429 will be hashed. So hash function of word. So and then for each of those word, and then hash function will be calculated, and then the minimum. So so this function here, I times x plus b mod p, then mod number of words. So say yeah, so 3429. If I go down, so there is continuous bracket. So say it above, words per doc of doc ID 3429. So for all of these word IDs, the hash functions will be calculated, and the value will be calculated, and then the minimum will be taken and put into this place, signature matrix, but row number 9 and doc ID 3429, and then a retain signature matrix. So call the function to compute the minimum signatures for all documents. So signature matrix equal compute signature matrix of hash functions and words per document. These are the inputs and signature matrix. So you can see ninth row and column 3429 is 1. Okay, so to measure the time taken to calculate MinHash signature with 10 hash functions, so what we will do is we will define the number of hash functions, that is signature size, number of hashes equal 10, and then we say let start time equal time dot time, open and close bracket, call the function to find hash functions. So hash functions equal generate hash functions, bracket, number of hashes, which is 10, comma, number of words, which is 3430. So it will generate the hash functions here, and that will be 10 hash functions, and then call the functions to compute the MinHash signatures for all documents. So signature matrix equal compute signature matrix, bracket, hash functions, which will be which are the functions that we computed, and comma, wordspace doc, and wordspace doc is the nested set of doc IDs and the word IDs. Then print, so time taken to calculate MinHash signature using 10 hash functions, colon, this Kelly braces in 0 will be replaced by this uh, format, bracket, time dot time, open bracket, minus start time, close bracket. So, and then seconds. So there's a dot to separate those. So yeah, so that's 1.39 and so on seconds. So display, not bad. So 1.39 seconds, which is quite low. Display signature matrix. So signature matrix looks like this. It's 10 rows and 3430 columns, because remember the signature matrix is number of hash functions, which is 10, and the number of columns is number of documents, which is 3430.